getting cold.
Yeah, I press record, by the way. I was talking to somebody who had just left Atlanta and they were in Minneapolis, and they said going from 97 to 45, it was a bit of a shocker for them. So what's going on? I'm spent a little bit of time, apologies again for not making Tuesday night. I spent a little bit of time on trying to get my transmission under control. I have out in the, where's the share button? There it is. So out in the G drive, I've got the speed control code that I've been using. This is what's, again, as a reminder, my setup is this code. It runs on a Teensy that's embedded inside of the Super Servo. So its function is to subscribe to listen to command velocity, listen to the left speed, and it sends the commands to the servo about what to do. I also publish that statement purely from a debug standpoint so I can see what is actually being written. So my next step is to get this all organized, or get this tested with the wheel on and the engine running. I've tested it without the engine running. Fundamentally, it's based on what was in Matt's velocity control function, so I still have in there settings that Matt had set about minimum value forward and minimum value in reverse. I know those need to be adjusted. I as well have his KP and K, I think settings in there. And I've changed the code just a little bit to make these variables. I think, Matt, in your code, those things were constants. So I changed those to variables. So it's a little bit, and then this is where the actual microseconds are written to the motor controller. And then I saved that to publish it. I had an interesting problem in that I was getting all of these serial port failures and other odd things that were leading me to a really odd place. And I realized what was going on is if I didn't have command velocity running, as you guys have coached me in the past, to make sure that the neutral signal is being sent to the servo. If it's not, if command velocity is not running. And so this fail-safe thing, I was to keep track of the PWM value that was actually being sent to the transmission. I wanted to publish that, but this was running, I clocked this thing and it first said it was running at 400 hertz, and then it slowed down to 200 hertz. And so I was just overloading the data bus. So I took that out and then just published that on a slower interval, like 10 hertz, and my errors went away. So that was cool to get that debugged.
That's great.
So it's all working in without the motor running and whatnot. So now I need to fire it up and tune the PID and make hopefully final adjustments. So that's where I'm at the moment. Oh, and I ordered one of those servos that Jeff mentioned were on sale at, is it MPGA? So that arrived this week, but I haven't played with that at all. I also created a copy of the milestone plan and was just going back to try to clean that up a bit. I haven't changed, so the previous one is still out there, but I just started one to make it a little bit more simpler and get my steps more organized so I could get my documentation more in line. So at the moment I'm down here on step 23, test the transmission, and so that's the other thing I did, and I moved my detail tasks. I still keep track of my detail tasks by date. So just to try to keep the documentation, it's not pristine, but it's better than a stick in the eye. So that be where the Pittsburgh contention is.
So you feel pretty good about being able to get the speed control?
I do. I mean, it's, what do you say, if it's sort of working, you're probably 20% done. I mean, it's got to bump around the yard and all that kind of stuff to see if the left speed sensor is going to be resilient enough to handle that. But yeah, logically, I think it's going to work. I mean, I need to test, tune the PID, and but I'm hoping, since you used a super servo and I used a super servo, that it'll be pretty close. So I can get a few hours on Saturday. That's where I'll be.
You have some kind of remote e-stop connected?
Before I take it off of blocks, I need to get that resolved. I've got the equipment. I don't have it connected in. I have the manual red button on the unit, but I don't have a off vehicle remote stop wired in yet. I just have one of those 12-volt deals with a key fob on it. The way I wired the onboard red stop, it should be easy enough to put that in.
Just handy to have somewhere to stop it before you turn it loose in your yard, in case it doesn't go where you expect it to.
Which, of course, it won't, right? But yeah, safety first. Still up on blocks at the moment. Anything going on in your world you want to share, Jeff?
Well, we were talking about how would we mount one of those servos, and basically I just took a flat plate and cut it the size of my frame that I want to put in, and just drilled 5 holes in it. So it's got a clearance hole for the shaft and the 4 holes to bolt on the front of the motor. And if you look on the internet or on eBay, it shows you what the hole patterns are. So I just drilled that, and this is that plate, the $13 plate that you can order from China. You can get them from $12 to $15 or something a piece. And I do have an extra one of those if you need one of these and you don't want to get it from China.
Can you post the link to that place where you bought that mounting on the servo?
Yeah, I can whip up something here. It turns out that the way people sell these, they say, here's the servo, or you can buy the board, or you can buy the mounting plate, and you just got to pull the little pull down thing, and it shows shows where to get the plate. So I'll whip that up here.
I was having a hard time finding that plate that fits that servo.
And when I put it on, it seems to fit really well. It turns out it's got 2 set screws. There's one there that's an actual screw, and then around here there's another hole, and they're 2 different sizes. So they sent me 3 screws, but they're all for the smaller one. So this bigger one's probably an M4, and I haven't verified what it is yet. But so it does have 2 set screw holes, and the one on the flat is I think it's an M4 on the one for that. And this is a steel one. I was thinking the one on the Servo 200 was aluminum, but It's underneath and I can't see it right now, so I don't remember if that was aluminum or steel on that one.
Mine was aluminum. I'm not sure if we have the same one.
I mean, what I posted is the servo mount. I mean, Jeff, he fabricated his servo mount, but he bought the shaft mount. Are you interested in the shaft mount or the servo mount?
That little D slot ring that goes on that shaft.
I'll go look it up here.
I wanted to be able to have a spare one before I started drilling on mine in case I got that all messed up. But I looked around and didn't really know what to search for, that D pattern inside of there.
It took a while to find. They call it. Well, when I find it here, we'll find out what they call it. They call it something slightly strange. And so I'll go dig for it here. It's probably on my history or something, so should be able to pull it up fairly quickly.
Yeah, I was just looking too, because I thought I'd found a couple of sites with it as well.
So when you search, they call it an alloy arm plate. So and this one's actually under here. Let me just share my screen here. How do I do this one? Screen. Okay, can you see that?
Yep.
So they list it as the 180 kilogram per centimeter servo, and then it says that they call it the alloy arm plate. And you can see here it's got this little pull down thing. So if you say, normally it comes up like this and shows you the servo itself, and then they give you a price of $61, and you can get just the controller board for $26, or you pull it down for the arm plate. Once you get that, probably if you put in DC 1224 and put in maybe high power servo and then put alloy arm plate, then a bunch of different ones will show up, different companies. And I just kind of randomly picked one, and like see right here is another one that's showing you. This was a 1330 with, well, let's make sure we get the right one. Well, I guess they always show you the cheapest part, so you think the servo is this price, but so again, it's called alloy arm plate. So that's what you have to search for.
Okay. I didn't.
You know, so in the picture here, it does indeed come with 3 screws. And this black one I thought would have been a bigger one to fit into the hole over here, but it turns out the hole is a different size. So I'm sure it's just simply an M4, and these are like M3 or whatever the sizes are. For some reason, they're 2 different sizes.
I didn't look at it close enough, but do you think this can be a continuous rotation servo?
No, it can't, because it's got a physical pot, and I assume it's got limits on it. It could be you could turn it all the way around, but I'm sure the software isn't smart enough to know even if it does turn all the way around. So that Servo 200 will turn all the way around. This one I don't think will. So that's to be decided, I guess. I want to get around trying to mount mine. I'll go ahead and solder the wire on the pot and verify I can get the signal out of it, and then see if that is going to be a nice stable signal or if it's too noisy to use or whatever. What I should do is, as I tear it apart, take pictures and make movies, because some guy on YouTube said, hey, can you post a video of your steering, how it works? And so before I rip it apart, I should take some pictures of the way it is, maybe make a movie as it is, and then disassemble the front end and give another explanation, and then I can pull the old Super 200 off, and I think this will just drop right in place. I just have to put it on, line up, and drill holes and put screws through to hold it down. I think is all I got to do. But I won't know until I try it.
Cool.
We did get on our wheelchair motors on this new thing we're building here at work. We bought some encoders from DigiKey. I think they're $26 encoders, and it's, for some reason, they're capacitive. I've never heard of capacitive sensors before, but it's basically, I just bolted it right on the back of the motor, and then inside it's got dip switches, so you can set it between 48 to something like 2048 counts per revolution by just setting the switches. And I've never seen that either. So it was kind of a slick deal that I was worried I was going to have to mount it. The shaft wouldn't stick out far enough. The shaft sticks out like 7 millimeters or something beyond the back, and the spec says you need a minimum of 9 millimeters. But I went ahead and put some washers on to shim it up and jam they give these little plastic adapters also. So you can use it from anywhere from like a 1 millimeter up to 8 millimeters shaft. You just pick the right plastic piece and put it on your shaft. You press the little thing onto it. So it's really slick. And so if you're trying to do anything like that, that's something worth looking at.
Have a shaft sticking out 7 to 9 millimeters.
Yeah, they want the shaft coming out of the back of the motor to be, or whatever you're hooking onto, you got to have a shaft that long. The numbers I just quoted, the shaft diameter, you can put on shaft diameters by putting these little adapters on there.
And then how does it mount up to the motor?
Well, basically you press this adapter onto the back of that shaft, and then I just laid the encoder on the back of the motor and made 2 little holes, and I drilled and tapped those holes. In the first hole, I drilled down and I had no problems. The second one drilled right through the back into the open space, which surprised me. And then, so when I did the second motor, I turned it slightly. I turned it like 20 degrees or something, thinking maybe I can catch something else. And both of those drilled all the way through. So that's not what I should have done. And ideally, you should take it apart and look at it, but that's the end. It's got the brushes on. So if I take it apart, the brushes are going to pop out and it's going to be a mess. So I just left it. And so far, it hasn't burned anything up. Hasn't shorted anything, and I don't hear it grinding. So, but basically, it's just you just stick it on, put 2 screws, and it holds it on there.
See, I'd be wringing my hands and like, how am I going to do this? And a week later, I'd still be messing with it. You just drill in there.
Well, the original one, because the guy that used to work here and left and then decided to build a robot lawnmower, he's got the same wheelchair motors, and he's got this encoder. That's what he said, oh, put this one on. So I looked at that one, we ordered that one, and he did some kind of a 3D printed bracket that you screw onto the back of the motor with the existing holes. And then I think he printed something that goes over this big hex nut that's normally on there and made a shaft coming out. So he had 2 or 3 things stacked up there. And I thought, well, I'll just try putting it right on the back of the motor. And I did that and it worked. So at first I think we just tape it on there. And then their guy says, hey, we'll just glue it on. We'll use super glue or something. And about that time, the mechanical guy walked by and says, oh, if you're going to tape it, I'm not going to let you take it out of the room here if you do that. So, but I ended up drilling and tapping, and it seemed to work out. Seemed to work out quite well.
That's cool.
I haven't powered it up yet. That's what I'm getting ready to do now. Go try that.
Anything else come across your desk lately?
I keep thinking I'm going to go out and test my robot. I want to have it so I hacked a piece of Python code that I was using on previous ones, so I can now get the messages coming out of my microcontroller where I just have like 6 or 8 fields as an ASCII string coming out, and this Python thing just connects to that board and then converts that into odometry, topic, and a transform. So I'm able to publish those now. So I was going to put my GPS on there and have it publishing, so that way I can take it outside and fire up Ross Bag and drive around and see if my odometry is matching my GPS as I drive around. But I was thinking the easiest way to do it is to lock the 2 together. So if they both start in the same point and the same heading, I'd be further off, because then when I pull up stuff in Excel to plot it, at least the heading will be the same, so they both start in the same direction. And then I was surprised when I was looking at this, because I didn't realize that when you publish an odometry message, you take your heading and convert it to a quaternion, and it never publishes the actual heading. So this Python script that I had also takes the existing data right out of the microcontroller and publishes that as a topic. So I can save that one, which has my X, Y, and heading, and I don't know, 2 or 3 other things that I need to generate that odometry message. And that way I can use those directly in Excel. And the only difference will be, if I can get all that to work, is that I'm reading the ECEF X and Y location instead of latitude and longitude. And either one I do, it's going to be some absolute position And what I need to do in my Excel then is take whatever the first locations are and call that my origin and subtract it off everything from then on. And that way my GPS will say it's starting at XY at 0, 0, and then a heading of 0 because I'm going to line it up, drive it till it says 0 degrees. And then my odometry, I'm going to hit the reset button and that'll set that to XY of 0, 0 and a heading of 0. So that way everything should be, they should line up exactly. And then as I drive, probably my scale is going to be off and the rotation is going to wander, but it'll be something that I can directly compare then if I do that.
Why not just use your GPS as truth for odometry, and then just update. So what I did is I have wheel encoders on there, and then if you can just map it to a button, but you can send in mine just listens to a topic if I want to reset heading, and then what it does is it sets the wheel odometry node to the GPS odom.
So you load the actual position into your odom, the X and Y?
Yeah, X, Y, and heading from the GPS. I use that as ground truth. That's the most accurate sensor. And then I can just push a button and then it will reset. It will reset your wheel odometry to whatever your GPS odometry is. It's like if you were doing a circle, you could run a circle, and then reset it, and then do the other side, or do whatever you want. But then you're doing the same. You're normalizing the data. You're normalizing to odometry message just by using the GPS.
The problem I say with that is that coming out of the GPS, I either get latitude and longitude, which is some stupid number, or I'm getting this ECEF, X and Y that are in like 250,000 something meters. So it's just a huge number. Actually, it comes out in centimeters, so I get this giant number that I'd have to load into my odometry, which may or may not be a problem. But I just wanted to, I thought I'd get everything back down to 0, 0, and that way it'd just be easier, mentally to look at and say, okay, that's how far it's drifting or whatever. So, and I can try various things and see what it does. If it's putting out all the numbers, then I can go back with Excel or whatever and hack on the numbers to correct them or whatever, to compare them that way.
Yeah. So I do use local coordinates to compare. I just use GPS pose, and that will take in your lat long and give you 0, 0 wherever the robot starts and moves around. But NavSat Transform does the same thing. There's a number of packages, or you can just do it yourself. You can build a node to do it yourself.
Yeah.
But NavSat Transform will output a pose, and it will also, GPS pose will output odometry as well as your pose, so you can use either one. NavSat Transform, I think, just does your, I don't know what that one outputs, but it outputs your local coordinates, maybe as a pose message.
Yeah, I just try to avoid putting all these extra little nodes in there that may or may not be doing what they're supposed to. So I just want to get the actual values for both units, and then I can compare them directly before trying to use somebody else's, some third-party thing in between there.
Yep.
Or I could write my own node, take my ECEF and say whatever when I reset the odometry, I can just save that as my origin and subtract them off, so I'm actually creating. So I just subtract off the origin on my GPS at that point too. So I got several things I can try.
That works multiple ways.
And the other thing I kept thinking, well, how am I going to do this? Because I thought what I need to do is line up my robot so it's going north, so it says 0 degrees. And I thought, well, I could hook up a laptop and do a Ross topic echo to watch the heading coming off the GPS. So if I just use a single GPS, I can use course over ground, watch that until it says 0, or I can use my dual antenna and watch my static heading. And when that says 0, I know I got the right one. But now again, I got a laptop out in the daylight, you can't read it. So I was trying to think of different ways to do that. And so one of the things I thought of was I added some on my remote control. I got extra switches on there. So I've got one switch. When I flip that on, that's what resets my odometry for me. So it's like you said, you had a service or a topic or something to do that. Basically, I just have something in the code that says, if I turn that switch on, I just slam everything to 0. And then I was thinking for the GPS, another thing I could do on the GPS, I can just simply have something that's watching the heading and have a light that comes on. So when I'm pointed at 0 degrees, the light will come on and say, okay, there it is. So I don't have to watch the stuff on the screen. And I kept thinking, well, it should be nice to know how far off I am. So I'm back to this, thinking about this LED strip again, so I can do a bar graph. So I can do the thing where it's right in the middle, right at 0 degrees, it'll say, it'll be yellow, and then to one side is red and one side is green or whatever. So I might go ahead and try that too before I get too carried away here. And I don't know if I'm going to drive that from Ross or from my microcontroller. It'll just be a matter of probably whatever's the easiest right now. I've got that one little board that I demoed. I can just plug that into a USB port and drive that directly from Ross. So I'll just have a node that says, grab the heading and scale the whatever it is, and then do my little slider back and forth. So that might be a fairly quick thing to do.
Do you have moving baseline on your robot?
I do, you know, it's like a 10-minute thing to either put it on or not. So right now I got both boards are bolted to a single plate that's taped on there. So it's just a matter of sticking on another antenna on the front with a magnet and plugging it in. And then I have to fire up 2 nodes instead of 1. And then it actually publishes a ROS topic of the moving baseline. It's got a bunch of junk in there, but one of the fields is just the angle in degrees, I think is what it comes out as.
Okay. You mentioned north as 0, and that's NED, but there's different coordinate systems. And
yeah, I know Ross does all that, but again, I want to do the simplest thing. So coming out of the GPS, I think it says north is going to be 0, and I'll just say as long as I point my robot in the right direction, my odometry will think that's 0. So again, without going through too many different translations and all this third-party stuff, I just want to get the simplest thing coming out and verify whether or not it's working. And I realize Ross thinks that north or the east is 0 degrees, but right at the moment, I don't care. I think I could just throw in a 90-degree offset later to correct for that. So we'll see how far I get on that.
Matt, anything going on in your world besides home remodeling?
Playing around with Docker, having fun. Trying to simplify your milestone list, combine that all into one package.
Yeah, that'd be cool. And you were saying earlier about the guys in Argentina. Well, what's their status?
Working on GPS, getting odometry. So kind of a similar situation.
And you mentioned their solution is the Pixie.
That's the GPS they had. So it's like what's the name of your GPS that you're using?
I have
ComNav.
one of everything, but the most stable has been the more expensive ComNav units. I think it's model K501 or 701. Yeah, it was a 501, and I think they've upgraded to 701. Anyway, all that's still in front of me, although I've had it working before in the old solution with Argent Pilot.
I'm told that we're going to order some the new Hemisphere V200, and it's got a dual antenna inside of it. And we tested the I think it was a V104. They gave us one on loan to play with, and it was single constellation. It was GPS only, and it was single frequency only, so it only did L1. So I didn't expect it to work at all, but I was surprised. I stuck it on my car, and when I powered it up, within 30 seconds, it said it had a fix, and maybe another 30 seconds, it said the INS was locked on and giving me a heading. So I was surprised with that. I went out and drove it around, and it seemed to maintain a lock. And I think I go back and look at the log files. You can see the GPS would drop out, but the INS would still maintain your heading. So it's got some kind of IMU built into it, and somehow they fuse all that together. And the thing was, when we were looking at that, they said, "Oh, but we got the new one coming out for about the same price." So the V200 has, again, it's dual antenna, and this one now it's multi-constellation, so it picks up, I think, the four standard constellations, but it's still single frequency. So we'll see how that works out. And I think they claim it'll get down to like 30 centimeters or something, uncorrected. And then this new one, you can get something called Atlas correction. So if you pay them money, I think it's like Novatel does, where it sends you correction data right off the satellites. And I think I heard somebody say, well, we'll go ahead and get that too. So I may have some information on that as to how well those work. And I think you can buy it either as a CAN only interface or a RS-232 interface. And of course, we have to buy the CAN one, so we'll experiment with it that way. But I think you can order it the other way. And I was thinking the first one they told us was around $1,200, and then when it was mentioned we're going to get with you, so what are they around 1,200? And the quote that he pulled up, which he said for 5 units, I think this is $575 a piece for these things. And then it's like a $100 cable if you want to buy the cable and all this kind of stuff. So we just go to eBay and buy a $10 cable. We don't need the fancy ones. So we'll see when those show up, how well they work and how accurate they are. And it'd be nice to see how accurate it is with and without the correction. And especially since it's single frequency, I didn't expect that to work in the beginning, but the first one we had seemed to work, and we'll see if the new one, how well it works when it shows up.
Who is the manufacturer?
Hemisphere.
Yep, there they are. Neat. Yeah, I see their Atlas link here. Atlas Link GNS Smart Antenna. Well, that's just the antenna. Do you guys get the OEM board, or do you buy a packaged deal?
For the Hemisphere stuff, it's just a packaged plastic thing you bolt on top of your vehicle.
Because they have OEM boards as well, it looks like, which is what come now. So. Cool.
I just posted the link to those servo arm plates we're looking at. You can click on that, see if that works. I don't know if it's awfully long for whatever reason. I don't know why it insists on doing that, but I was going to try to trim it down, but I just waste so much time doing that. I just posted the whole thing. So
Yeah, it comes up.
We'll see how that works.
Okay, guys. Matt, anything else?
More fun.
More fun. Jeff, any more fun for you?
Not that I can think of.
Well, we will see you guys in the Slack channel. Good luck over the next few days. You guys have a great weekend. We'll talk to you later.
Thanks.
Okay.
Yes.